Hello YouTube, welcome back to Cooking Components. What I've got here today is a broken Roland SC-88 SoundCanvas I got from eBay. Unfortunately, like you might be able to see, the screws are a little bit scratched, so someone else was in here before we could take a look inside here. But from what I can see on this device, it might even be a very easy repair. I hope for this video it's not, but I don't know if you can see this. But I think there's a reset switch down here, and it looks like somebody had fun and it's still stuck in the actuated position. So it might be that if this device doesn't turn on, it's just a problem with the reset switch because it's stuck. So let's just try from the eBay listing. It should turn on the display backlight, but there should be nothing visible on the display. I hope it doesn't explode. Okay, it turns on. I can see lines on the display. I think you can see them too, but nothing happens. If the light wasn't so bright here, you could also see that there's light in the display. Okay, let's have a closer look on the reset button. So I don't know if this is very visible, but there's a small little reset button, and it looks like that this reset button got a little bit of a hard jam and is actually stuck there. I hope you can see it move when I try to move it. Oh, yeah. Okay, it's just wiggling around. I really don't know what this is. If I try to press it, nothing happens. Okay. So let's just give it another try. I hear humming from the power supply. But nothing is happening. Okay, then let's just unplug the power and take it apart. Okay, I need to be careful because of the buttons in the front, so that I don't push down too hard. I might break the front panel. Now let's just reveal the insides. Ooh, I see a lot of PCBs. So, because we have this kind of dicky switch or whatever it is in the front panel, I think I want to first take a look at the front panel. Okay, something's not moving here. I'm not really sure how this is supposed to come apart. Oh, something is moving. Oh, there is a screw down there, and I think the part behind the screw is connected to the front panel. Okay, we got the front panel. Can I release this plastic part that's connected to the switch? Oh, no. Okay. Whoops. So this is a mechanism that grabs around the switch. Please focus. Okay. And there's a small plastic part which can be brought to the front. Then the this connecting rod is fixed to the switch, and when you pull it back, you can move it away from the switch. Okay, that's the plastic part where you press on to actuate the switch. It might be that these cables are too short. Okay. Nope, I can lift it. Ooh, there's a whole lot of stuff in the front panel. Let me just get these connectors off. Okay, got them. Might just have been easier to get the main board out. Okay, I think this now lost switch is completely gone. Or somewhere behind here. So I'll just try to get off the board on the bottom. By the way, this front panel is nicely shielded. There's complete foil behind the front panel, it seems so. I'm starting all these screws in there. Okay, I hope I won't lose all the screws now. Not the screws, the buttons of the front panel now. Because I feel they are getting loose now. Okay. I don't see the missing switch. Oh, no. You see this part? So this is a small plastic part. That's a light pipe. where an LED will shine through, and I can clearly see there are marks of a biro on it, or a pencil, and I think this has been mistaken for a reset switch, and I think that's the plastic part that was moving around. And as you can see on the other side, it's disconnected, so there was a plastic welding which hold it in place, and it disconnected from that plastic welding. And I think the reason was the force that was put onto this mistaken switch that made it come loose. So I'll clean that part up and I'll try to put it back in place. But we will now try to find out where's the problem with this Roland SoundCanvas. There are some screws on the back that are holding onto the PCB. And also, I think, onto this connector, or these connectors. I can feel the PCB coming loose. So this seems to be the main board, and under it are, I think, under this metal bracket is the power supply section. You can see that big transformer here, but there's more regulating stuff in this section, and I think here is an audio input, mixing and output stage, because on this device you can feed in an audio signal from other devices and output the audio signal of the SoundCanvas plus the audio signal you fed into this SoundCanvas. Okay, I think I'll try to get this front panel out of the way, and the only thing that's still connected is the display, but there might be a way to open this connector. Okay, I can lift the plastic lid from the bottom up, and I hope I can free the cables by doing this. Okay, this time the small latch from on the top helped me. Now we can get the cable out. There are a lot of cables in this device. Okay, we got them all. Okay, there seems to be a little bit of corrosion on the top and the bottom of this capacitor. Also, the other capacitors have soldering points that don't look very clean. I can't tell at the moment if this is a problem of leftover flux residue or if these capacitors all are just a little bit leaking, but we'll find that out later. Also, we need to measure the battery, but I think I'll try to start with the power supply, because I hope, and that would be the easiest fix, that the problem is related to the power supply and is an easy fix, because everything else or everything not related to the capacitors could be very complicated. Even finding this ROM you see here in the middle might be a little bit of a problem. So then let's just start trying to get the bottom PCB out of the shell. Oh, a nice attention to detail. They have here a small plastic covered metal strip that's used to hold the cables in place. And where it grabs the cable is also wrapped with a little bit of what looks like electrical tape. And again, screws on the back. Two screws that hold the heatsink of the, I think, the power supply transistors in place. And two screws that hold the output and input jacks in place. I can feel the PCB getting loose. So this is our power supply and I think output and input amplifier and mixer board. So there's the money shot for all your Texas Instruments, I mean Burr Brown fanboys. This is a PCM 69AU. That's an 18-bit digital to analog converter with 2 channels, so you can use it for example, stereo audio. And I think this is the main output for whatever sounds the SoundCanvas creates. Ooh, it has a lovely golden colored case. It's a standard plastic package, but they've colored it in a lovely shiny golden tarnish. So after a little bit of looking around on these boards, I decided to just build this up again, open on my bench, and try to measure voltage rails, because there are the voltage rails and they are nicely marked. Also, there is a reset pin. I don't know if this goes to the mainboard, because the mainboard doesn't even use this big connector that's on the board. It just uses these small cables. So I have my multimeter set up here, and we can just try to turn it on. I hope it doesn't explode. Looks good. And try to measure voltage rails. So the only open available ground I found was this one here in the front, because these other ones aren't connected to the ground. Only this ground pad is really connected. So let's measure the reset. That's high, that's on 5 volt. That should be good. The negative 12 volt rail looks good. The analog ground looks good. Positive 12 volt rails is on 12 volts. So then there comes the digital ground, that's also on ground. And the 5 volt rail for the logic. So all the rails are good. I'll just try to confirm that on these capacitors. Okay, I don't know if I have contact. Okay, that's 5 volts on that capacitor. And I think over here we will also get, oh, that's not my 5 volts, that's my 5 volts. Okay, so I already checked the battery. The battery is still on 3 volts. That should be enough. So I will need to search for something else. So power rails are there, but nothing is happening. So after digging around a little bit on the internet, I found a schematic of the Roland SoundCanvas, and I've just marked where the reset signal comes onto the board. So the reset signal is generated on the power board, and it's just controlled by the power. So when the power supply has all the voltage rails up and is good to go, then after a couple of milliseconds the reset is released, so the CPU on the mainboard can start running. So the reset signal comes in, and there is a buffer with 2 inverters, and I think this is just to clean up the reset signal and give it a lot of power, because it is used on an awful lot of places all over the board. So there is the CPU. I think this is a sound chip or a DSP or something. There is the NAND gate, I think, that's controlling the chip select signal of the RAMs. And there is a mute signal. There's a power signal to the MIDI out and through connector. All the other MIDI connectors don't have a power signal, but this one has. I'm not a MIDI expert, so I don't know why. I think the first step now would be to measure if the reset signal leaves the inverters correctly, and then perhaps try to find out if the reset signal reaches the DSP and the CPU chips. Okay, we should start with pin 5 of the logic IC and then go to pin 54 or pin 1 of the DSP or the CPU. Okay, I have soldered on a ground pin previously, so I can ground my oscilloscope probe, and I'll go to the pin 5 of this logic IC to grab the reset signal, and I'll go to a power signal for reference. So I hope you can see the oscilloscope screen that I've mirrored onto my laptop, because I couldn't just fit the oscilloscope onto the screen as well. Okay, we have a reset signal, but we are too far in to see the other signal, the power signal coming up. Oh, that's not easy to use. That's a lot of clicking and hoping that the oscilloscope reacts. Okay, I have my time bias. I'll reset again. And there's my signal. So you see a lot of distortion. I think that's from powering on. I think the transformer here or something else is coupling into my oscilloscope signals, so we have this awful lot of distortion here. So we have a lot of noise on the power rail, but that is due to that I don't have a ground pin connected on the power rail. The reset signal is much cleaner. And as you can see, the reset signal comes roughly 40 milliseconds after the power signal is good. So we can zoom on the power signal. And oh, that's too far. You can see it ramp up, and after the ramp 40 milliseconds, and then the reset line is released. So the CPU can theoretically start. Okay, then off. So here is pin 54, and I think it goes to that via over here. Oh, my probe is collapsing. Come over here. Okay, there's a signal. Here again, too far out to see something. That looks good. It looks the same as when we measured directly on this chip. So can I change my memory depth? Okay, perhaps this will make the zooming a lot easier. So next is pin 1 on this chip, and the trace goes to this chip and then this via, so both these chips are connected to the same reset signal. Let's measure it. And we still got a nice signal. So the reset pins are working. Now we can check the crystals. So power's off. Okay. So we have the crystal of the main CPU here. There's not a frequency. There's a frequency, 20 megahertz. Then there's an inverter pair that's used to make the crystal swing and then amplify the signal. So the CPU gets a powerful signal. And for the... yeah, let's just measure this. So we have here the CPU. We have the 20 megahertz crystal, we have the inverter, and I'll just try to measure the signal here. Okay. Oh, and we just see not an awful lot, or we see an awful lot of yellow, so we are too far out to see our signal. Oh, it's reacting very slowly. There is a signal. So, can we measure it? Measuring. 20 megahertz. Perfect. Okay, that signal is working. Now the other chip. We have here a crystal, 24.576 megahertz. Also with two inverters, and it then goes into the chip. So let me just put my scope probes on there, and this one again on the power, just for good measure, and turn it on. And we have a signal, 25 megahertz. Okay, I think that's not a really accurate measurement, but at least we know the crystal is working and it's roughly around the correct frequency. It's somewhere between 25 and 24 point something megahertz. So this should be correct. Perhaps I can get a better measurement when I adjust my time scale. Yeah, okay. Looks good to me. So before struggling too much, I just decided to take the old capacitors off and switch them against new ones, because okay, there are some points that look suspicious on the capacitor leads, like here, and especially on that one. But Roland is known for using very high quality capacitors, so it shouldn't be there shouldn't be a problem. It should not be a problem. It might be just residue from soldering, but before struggling too much, I'll just rip them out and replace them against new ones. I need a little bit more heat. I'm sorry, man. Okay, soldering with the soldering iron upside down. If it works, it works. I won't complain. I think I have a great tool for soldering, but for these capacitors and that huge ground pads, I'll do the old wiggling trick. Okay, I know you can't smell this, but there is a funny smell coming from these capacitors while desoldering them. And on this capacitor, even the solder is contacting to my soldering iron very poorly. So there might be something on there. Oh shit, that looked a little bit like I lifted the pad, but I'm not sure. So now to the cleaning part. So, do you remember at the beginning of the video when I told you, the soldering on this capacitors looks a little bit rough, but that's most probably from the flux residue that's not leaking. I think it looks a little bit like leaking corrosion over here. Yeah, that's corroded, but okay, you might think that's just a stud from a ground plane that's connected to nothing. It's a little bit corroded. That's okay. Nothing to worry about. On this capacitor, it's a little bit more, but you can rub it away. No problem. Here, you don't even see the corrosion on the first side, but a little bit here, a little bit there. Not a problem. Also here, it's even more faint. Okay. Nothing in this picture? Ooh. Ooh, the straight is completely black. Ooh, that's not good. Ooh. And look at this wire. It even looks like there's no trace going away from this wire, but you see clearly there's a green trace starting and going away from this wire. Ooh, that's not good. I mean, okay, most probably it's not an important signal. But I think we need to investigate that. Can we get it on a better angle? Yeah. That might be easier to see. There's a trace. Completely blackened. A little bit of green might be left to see. And on the wire on the bottom of this trace, it really looks to be not connected to that green trace there. It really looks to be not connected. Ooh, nothing there. Ooh, I think we need to investigate. So, do you know what this pin is connected to the black trace? That is pin 57 of IC11. IC11 is this chip here, and here pin 57 is marked as A0 or address 0, and this pin is also connected to IC17 pin 21 we measured before, and a lot of other pins on this bus, but this one is handy just to grab with a multimeter. So we can now measure the connection between this pin 21 on IC17 and pin 57 on IC11. So let's try this. So let me grab my multimeter. In continuity mode, so you can see it a little bit better, I hope. Okay, it's sensitive. So we have IC17 with pin 21, and we have IC11 with pin 51, 2, 3, 4, 5, 6, 7. Nothing there. Just nothing. Okay. Let me go to normal resistance mode. Perhaps something is to be measured there. Ooh. That's a lot of ohms. 27, nearly 28 mega ohms. So no signal is going over that connection. So then we have this via left, which I need to figure out where it's going, but it's very close to our signal we just measured. But I can't see where it's going at the moment. So it looks like that there's a small VR here right on the edge of this IC socket, which is connected to this VR up here. And again, we have a very high resistance. But let me just try to poke around a little bit on this connection. Maybe I can find the trace and make out that it should actually be connected to this wire. Looks like I'm having no luck. Ooh! Ah, there's our connection. So you see this trace is clearly connected to this via, but the via that should be connected to this trace is not connected. So I'll just need to fix this connection and the trace up here. So I'll just clean this connection point and the trace with this glass fiber cleaning stick. And then we'll try to find a new connection. The really black trace just looks good. Can't see if it is somewhere broken. Yeah, okay. It looks like there just might be something that's not quite good. But this one with the via, that one is clearly completely broken. I need to find something to pick a little bit more on it. See that? There is no trace coming back. Nothing. Let me just verify if the trace that was so black is really broken, or I did measure something wrong. So let's do a little continuity check. Okay, buzzer's working. Get the trace down here. Okay, that looks okay. And this trace down here. Nothing. That's okay. Nothing. Okay, this trace is really broken. And on this one, I might just have measured the wrong trace. So I'll grab pin 21 on IC 17 again. Nothing. And that's okay. Okay, I miscounted. That's my bad. But the trace down here, that's done. See, I can get on the trace. I can get on the tip of the trace. Everything is okay. And I can get on the via. Nothing. There you can see it. It's broken. Okay, then let's clean this a little bit more and get it fixed up. So I just disposed the glass fiber traces somewhere safely. Now a little bit for the rubbing alcohol. Might be that this hole is blocked with solder like the other ones, so I'll just flip the board and try to find the hole. Where is it? There is it. Then we'll clean it up, put a wire through it, so we'll just free this wire from its solder. And I think there's still something stuck in there. Okay, I could push through it. And I'll just get a wire, put it through there and solder it on to both sides. So this is a single strain of a thicker wire. I think it was 1 square millimeter. And I folded it over through this wire, and I'll just solder up this end. And then I'll fold the other end up, cut it a little bit, and try to solder it to the trace. And then we have the wire or the trace from the other side connected to this trace that was broken. And I hope we have our SoundCanvas fixed again. we only need to apply the or solder on the other capacitors and apply a little bit of insulating stuff. And I'll just coat the other traces in a little bit of solder, because these traces are very thin. So I make them a little bit thicker, and I hope I'll also protect them against further corrosion. So let me just test my new trace. I'll go to the tip and then to the wire. Oh. Yeah, that's a good connection. I like it. Also, I'll try the wire that's near the IC socket from IC 17. Yeah, that's a good connection. Looks good. And the other trace from pin 57 to pin, no, that was not pin 21. What pin was it? This is pin 58. So let me just look that up. Oh, I just noticed something. So on IC 11, pin 57 is actually connected to A0, but on IC 17 there is no I0. Actually, it seems that the whole address bus is shifted one bit up. So A0 or address 0 from IC 17 is not connected to A0 from the bus, it's connected to A1. I don't know why they do this, so I need to find another spot where address 0 is coming to, and this would be IC 29, which might be the main processor. So I need to find A0 or pin 21 on IC 29. So this big thing here is IC 29, and I need to find pin 21. So we have here pin 28, we have pin 1, so 5, 10, 15, 20, 21, that would be this pin, and we can use the wire down here to measure it. So I'll put my probe on there, and then I'll shift over. Where's my IC? There's IC 11. And then I'll put my probe onto here. And we have a good connection. So that trace is working. We just measured the wrong connection. So then next up would be to get a fresh capacitor and solder it in place. So just a little bit clean. More rubbing alcohol. Just drown it in rubbing alcohol. It's a lot less visible. So, you're here for the magic moment. Did I just make an easy fix, a really hard journey and a long repair video? Yeah. I think we are not quite there, but at least the bars on the display are gone. So maybe I'll just need to reconnect all the rest of the connection cables and try again, because I think there might be important signals missing. Hold on to your heads. I just turned it on again. And I got something on the screen, so I think it's working again. What a bummer, just these bloody leaking capacitors. So we got here our new capacitor and the area that had been damaged and now been repaired. I'll clean it up a little bit. And then we will seal it with green UV curing solder mask. So we get this part on the PCB protected again. Now for the green sticky part. Just a little bit, oh, that's too much. It's not easy to dispense the correct amount. You need a thin layer of this green UV curing solder mask, because the curing is done by UV light, and that means it's not very transparent to UV light, so you can't cure it, a thick surface, a thick coating of it with the UV light. It needs to be very thin. And here comes the UV light. Yes, it's a self-built PCB with UV LEDs on it. So I got it on here for around 2 minutes now. Let's just test if it's still sticky or if it hardens through. Oh, that's not hardened enough. I think I'll stop here and let it cure for a couple of minutes. So I've let it cure for just shy of half an hour. So let me just test again, but it looks really different, so I hope it cured. So I don't see anything green rubbing off. So I would declare this for cured. And I think we can now start to put everything back together and test the unit. So I think that I just have here a really nice Roland puzzle, and I should just start and putting it all together again. So at the moment this tab is a little bit also in the way, because we need to get this tab between this metal plate and this outer shell, and the switch is a little bit long and just doesn't allow us to slide in the way we want. I might just loosen these 3 screws again, so we can just bend this metal plate a little bit out of the way. So now it has a little bit of plane here. No, that's not working. I think that this plate is on the wrong way. Okay, that was clearly on the wrong way. These people were just screaming at me. Oh no. There's just a connector I missed. So I need to get this front panel PCB out of the way again. So it might have been a little bit quick on putting everything back together again, but I'm really sure this will work. I didn't test it between the last test we did when display turned on, and it seems to be everything booted up fine. And now having it put all together. So let's just try it. So it still powers on. Now I need a MIDI source, which I prepared. I think the out cable goes into the in port and the in cable goes into the out port, but I don't care about the out port. So, and then we have an audio out. Woo! Which is a little bit noisy if you have your amplifier running while you are connecting it. Okay, looks good. Then let's just turn it on again. And there should be a test function, so I turn the volume down a little bit, and when you press the volume button, the last device selected should be playing. Okay, it's a little bit low. You might be able to hear it. Okay. And I have a test file from Roland on my PC, and I will just start it now. Ooh. I think I should turn up the volume a little bit. So very nice. The file is called Piano A, nothing more. And it seems that our Roland is playing just very nice. Can we... I don't know a lot about this device, but I think there may be a possibility I can change the instrument. Difference. Oh, did the file end? Okay, I'll try it again. Okay, it seems to change. Okay, that's a clear difference. Okay, I hope I don't get my video claimed for this, but it looks really good to me. The SoundCanvas SC-88 is rocking again, and perhaps I find something else to try out on this device. And just for the end of the video, I have something most of you might know. So let's just see the front panel while I'll start DOSBox. Okay. This part might not be that recognizable because I have the wave output from my PC not connected, so you're only hearing the MIDI output. But when I start into the game, you clearly know this song. So the next thing to do is, when playing Doom, you want to feed in the wave output from your PC. So you have the sound effects like shooting and enemies, and you have the good wave audio from the Roland SoundCanvas mixed together, and you have a really nice playing experience. So I think that's all for today. Thank you for watching and have a nice day. Okay. I just couldn't resist. I added a wave channel audio input from my computer sound card, and you can hear I can now shoot, but at the same process I noticed that this potentiometer on the back that is used to control the level of the audio input, that this is a little bit dicky, so when I turn it, you might hear some distortion in the sound. So I have it now on close to minimum. Can't even hear me shooting. I have it now in the middle and now on maximum. So with that you can decide how loud your sound effects are, and with the potentiometer on the front you can decide how loud the music is. So now I can just walk around in Doom and try to find an enemy. Oh, there are enemies. I'm only playing one-handed. Okay, I think that's working. And I can even change the instruments that are playing the music. So, or I can change settings to the instruments. So at the moment there is Distortion GT selected for the voice 1, and I change it to harmonics. Or I can select another voice, the second voice, that's Overdrive GT, and I can also select other voices. Or how about the bass? I think that's position 10. Okay, there's standard selected. That doesn't sound very impressive, but I can clearly change it. Oh, that's the nice thing about MIDI. You can change every instrument. Okay, what can we change? Let me see. Okay, I have voice 1 selected, and I can reduce the reverb. And the pan. I don't know what the settings are. Do this to the second voice. Okay. Really, I don't know what I'm doing here. Ah, that's a lot of fun. Okay, this doesn't sound like Doom anymore. That sounds like some other game, I don't know. Could be a child's playing game, FSK 6 or USK 6 or a little toy playing game, or but not Doom. This doesn't sound like Doom. Oh, it's reset the settings. So when the soundtrack starts again, the settings are reset because the settings are transmitted at the beginning of the MIDI soundtrack. Okay, I think that's finally it. Bye!